Good evening everyone, good evening. I welcome you all again to NEET Elite. I hope you guys are doing great, having a good time. So people, first of all, you can let me know in the chats if I'm audible and visible to everyone, right? Just let me know in the chats if I'm audible and visible to every single guy. Hello Dakshin, hello Tanzila, hi Ishpreet, hello Meenu, hi Arazu, hello Chitra, hello Bitu, hello Ashwarya, hello Sweetie Tiwari. Welcome back everyone, welcome back. Just give me some green signal first of all from the chat box so that I'll get to know that I'm audible and visible to you properly. Yes, I'm doing great. Ishpreet, how are you? Perfect guys, perfect. So as you all must be knowing, we are done with the chapter Redox Reactions, right? And on Monday we are going to start one more chapter, and the name of the chapter is going to be chemical bonding, right? On Monday we are going to start the chemical bonding chapter, right? And the first chapter of chemical bonding is going to be the basics of the periodic table, right? Which is involved in the chapter chemical bonding, right? Yes? Perfect. Hello Faisal, how are you? Thank you, yes, thank you. All right guys, so in the tonight's session what we are going to do is we are going to do the previous year questions which have been asked in your different medical competitive examinations, right, from the chapter Redox Reactions. Yes. So before starting the session, the ones who are new to the channel, let me introduce myself. Well, my name is Wassim Bhatt and I'm your chemistry master teacher writer on this NEET Elite channel. Yeah. The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking live on this NEET Elite channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well, okay? Welcome back everyone, welcome back, good evening. Yes, gamer, chemical bonding forms the basics of the organic chemistry, right, exactly. Perfect. Hello Vivek, hello Harini. Alright, so you can let me know in the chats first of all if you guys are super duper excited for the tonight's session. Let me know in the chats. Let me know in the chats first. Hello Hazel, welcome back. Hello Anthony, welcome back. That's great Ashwarya, that's great. Yes, P block elements I'll be doing too. Right. I'll be doing P block elements too. Wait for it. Okay, so people, let's get going. Let's get started with the first question which was asked in NEET 2020 from this chapter. And I'm sure all of you can solve this question properly. The question from the Redox Reactions which was asked in your NEET 2020. Give it a try. Let me know its answer exactly. Give it a try. Let me know its answer exactly. Well, I can see a lot of people are coming up with option B, and let me tell you exactly, you all are perfectly right. It's going to be option B, which is going to be the correct answer of this question. And how come? Have a look exactly, guys. The question says, what is the change in the oxidation number of carbon in the following reaction? So you need to calculate basically the initial and the final oxidation state of carbon, right? What about the initial oxidation state of carbon? Let's assume the carbon has got the oxidation state over here as X. Hydrogen is going to show +1 oxygen state, right? Because carbon is more electronegative than hydrogen, and there are 4 hydrogen atoms, net charge present on the molecule is 0. So from here you are getting the value of X as -4. So -4 is basically the oxidation state of carbon in CH4, right? What about the oxidation state of carbon in CCl4? Let's assume the oxidation state of carbon is X. Chlorine is going to show -1 oxygen state, and there are 4 chlorine atoms. Net charge present on the molecule is 0. So the value of X comes out to be +4. So +4 is basically oxidation state of this carbon, right? So what is the change in the oxidation number of carbon in the following reaction? The change is from -4 to +4. So option B is the one which is correct among all, right? I'm sure it's clear to everyone. Okay. Moving on to one more. The question was asked in your NEET 2019. The question was asked in your NEET 2019. Let me know its answer. I'm sure you all can solve this one. I've shown you the structure of CrO6 in the regular structure, in the regular sessions as well. Just let me know its answer fast in the chats. I'm waiting for it. Well, I can see majority of the people are coming up with option A, and you guys are perfectly right. It's going to be option A. And how come it's going to be option A? Have a look exactly how it's going to be option A. If you look at the structure of CrO6, right? Well, let me draw the structure of CrO6 first of all. This is the structure of your CrO6, right? Now people, if you look at this single bond between chromium and oxygen, oxygen being more electronegative will carry -1 charge, chromium at the same time will carry +1 charge. Similarly, due to this bond, -1 +1. 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 Due to this bond, it's -1 and it's +1. What is the net charge present on this chromium over here? It comes out to be +6. So +6 is basically the oxidation state of chromium in case of CrO6. The question was asked in your NEET 2019. Okay. Oxidation number of phosphorus in PO4 trinegative, sulfur in SO4 dinegative, and chromium in Cr2O7 dinegative are respectively. The question was asked in AIPMT 2009. Let me know its answer in the chats. I'm waiting for your answers. Let me know fast, people. Let me know fast exactly what is going to be the answer of this question. Well, I can see majority of the people are coming up with the option D. Is that? Let's exactly see, is it going to be option D or not? See guys, first thing, let's calculate the oxidation state of phosphorus in case of PO4 trinegative. Simple rule you're going to follow. Let's assume the oxidation state of phosphorus is X. Oxygen is going to show -2 oxygen state. There are 4 oxygen atoms. Net charge present on is -3, right? So the value of X will come out to be +5. So +5 is the oxidation state of this phosphorus over here. What about the oxidation state of sulfur in SO4 dinegative? SO4 dinegative, oxidation state of sulfur. Let's assume it to be X. Oxygen will show -2 oxygen state. There are 4 oxygen atoms. Net charge present is -2. So the value of X will come out to be +6. So +6 is the oxidation state of sulfur over here, right? And what about the oxidation state of chromium in Cr2O7 dinegative? If you look at Cr2O7 dinegative, let's assume the oxidation state of chromium is X. So it's going to be 2X plus. Oxygen will show -2 oxygen state. There are some 7 oxygen atoms. Net charge present on the molecule is -2. So the value of X over here will come out to be +6. So +6 is the oxidation state of chromium in Cr2O7 dinegative. So what is going to be correct answer of this question? +5, +6, +6. So absolutely you all were perfectly right. It's going to be option D, which is the correct answer of this question, right? Perfectly done, guys. Moving on to one more. The oxidation states of sulfur in the anions follows the order. The question was asked in AIPMT 2003. Give it a try. Let me know its answer in the chats. AIPMT 2003. So people, from these questions you'll be getting the idea of what kind of questions and what is going to be the level of the NEET examination, right? Okay, from these questions you can clearly have a look on it. Alright, let's start with the oxidation state of sulfur in SO3 dinegative, right? If I talk about SO3 dinegative, I'm assuming oxidation state of sulfur to be X. Oxygen will show -oxygen state and there are 3 oxygen atoms. Net charge present is -2. So the value of X will come out to be simply +4. So +4 is basically the oxidation state of sulfur over here. What about the oxidation state of sulfur in S2O4 dinegative? Let's assume the oxidation state of sulfur is X. So it's going to be 2X plus oxygen shows -2 oxygen state, 4 oxygen atoms, net charge is -2. So it's going to be 2X is equal to +6. The value of X will come out to be +3, right? Okay. So over here sulfur is going to show +3 oxygen state, correct? Now similarly, what about the oxidation state of sulfur in S2O6 dinegative? Let me write S2O6 dinegative. Let's assume the oxidation state of sulfur is X, so this is 2X. Oxygen will show -2 oxygen state, 6 oxygen atoms, net charge present is -2, right? So 2X value will come out to be +4, so the X value from here will come out to be +2, right? So the oxidation state of sulfur over here is going to be +2. Now arrange them on the basis of their increasing order, right? So SO3 dinegative, right, will come at the top because the oxidation state of sulfur over here is maximum. Then comes your S2O4 dinegative and then comes your S2O6 dinegative. S2O6 dinegative. So which option satisfies it? SO3 dinegative, S2O4 dinegative, S2O6 dinegative. Option A is the one which is going to be the correct answer of this question. I'm sure it's clear to everyone, right? Okay. Right, people? Clear to everyone? I'm doing great, Dinesh. I'm doing great. How are you? Wait. It's showing option B. Did I do a mistake in calculating things? S2O6 dinegative, it's showing +5. 2X plus oxygen is going to show -2 and there are 6 oxygen atoms. Net charge is -2. Alright, yeah. It's going to be 2x is equal to plus 10. X value is going to be plus 5. All right. Yes. Over here I did some calculation mistake, right? So the oxidation state of sulfur over here is going to be plus 5, right? So it's not going to be option B. It's not going to be option A. It's going to be option B, which is the correct answer of this one. Yeah. Perfect. Yes, Faizan, exactly. You're right. Perfect, guys. Moving on to one more. AIPMT 2003 question. A compound contains atoms of 3 elements A, B, and C. If the oxidation number of A is plus 2, B is plus 5, and that of C is minus 2, the possible formula of the compound is. We need to see what is going to be the possible formula of the compound, yeah? Let's exactly see how this one is to be solved. First of all, if I check the option number 1, A2, B, C3 twice, right? Let's see exactly, can this be the formula of the compound? First of all, there is no net charge present on this molecule, right? There is no net charge present on this molecule, correct? I'm assuming the oxidation state of A to be plus 2 over here. I'm assuming oxidation state of B to be plus 5 over here. And I'm assuming the oxidation state of C as minus 2 over here. I'll do the summation of all the charges present on the elements, right? And I'll exactly see is the summation of all the charges present on the elements coming out to be 0 or not. Have a look exactly. A is showing plus 2 oxygen state and we have got some 2A atoms, so I'm multiplying it with 2. B is showing plus 5 oxygen state and there are some 2B atoms. C is showing minus 2 oxygen state and there are some 6 C atoms, right? Let's calculate it exactly. It's plus 4, plus 10, minus 12. Is it coming out to be 0? No, it's not coming out to be 0, right? So A cannot be the answer. Let's check for option B. Let's assume the formula is A3, this is B, this is C4, and this is twice, right? I'm assuming A in the second formula is showing plus 2 oxygen state, B is showing plus 5 oxygen state, and C is showing minus 2 oxygen state. Let's check it out. Since A is showing plus 2 oxygen state and there are some 3A atoms, B is showing plus 5 oxygen state and there are some 2B atoms, C is showing minus 2 oxygen state and there are 8 C atoms, right? So this value will come out to be 6, this value will come out to be 10, this value will come out to be 16, right? So is this value coming out to be 0? Absolutely, this value is coming out to be 0. So it's absolutely will be option B, which is the correct answer of this question, right? I'm sure it's clear to everyone. Yeah? Okay? Yes, guys, exactly. You all are perfectly right. It's option B. The oxidation state of phosphorus in pyrophosphoric acid. What is pyrophosphoric acid? H4P2O7. This is your pyrophosphoric acid, if you remember, right? What is the oxidation state of phosphorus in case of your pyrophosphoric acid, right? What is it going to be? First of all, let's try to draw its structure. And I think we have seen its structure. Already in the earlier sessions. Yes. This is H4P2 and 7 oxygens, right? Let's exactly get to know what is the oxidation state of phosphorus over here. Understand properly. If you look at this phosphorus, it is P double bond O. Oxygen will carry minus 2 charge, phosphorus will carry plus 2. Due to this single bond, minus 1 plus 1. Due to this single bond, minus 1 plus 1. Due to this single bond, minus 1 plus 1. So what is the net charge present on this phosphorus? 2, 3, 4, 5. Plus 5 is the oxidation state of this phosphorus, and similarly, plus 5 is going to be the oxidation state of this phosphorus. So what is the average oxidation state of phosphorus? It will come out to be plus 5 only. Absolutely, you all are perfectly right. It's going to be option D, which is the correct answer of this question, right? Yes? Perfect. Next chapter, I'm starting on Monday, and next chapter is going to be chemical bonding. Next chapter which I'm starting on this channel is going to be chemical bonding, right? Which I'll be starting on Monday, yeah? Alright guys, what is the oxidation number of sulfur in Na2S4O6, right? I hope you remember the structure of Na2S4O6, and the question was asked in AIPMT 1998 as well. If you look at the structure of Na2S4O6, I hope you remember it. I hope you remember the structure of Na2S4O6. This is the structure of Na2S4O6, right? I've shown it to you many times. Now, S double bond O, oxygen will carry minus 2 charge, sulfur plus 2. Due to this double bond, it's going to be minus 2, this is going to be plus 2. This single bond, minus 1, plus 1, right? This bond won't make any difference. So this sulfur is basically having net charge of plus 5. What about this sulfur? It will be having net charge of 0 because on both the sides sulfur is attached. Similarly, this sulfur will have net charge 0. this sulfur will again show +5 oxygen state, right? So what is the average oxidation state of all these sulfur atoms? Average oxidation state. Total charge present on sulfur, which is +5 plus 0 plus 5 divided by total number of sulfur atoms are 4. So the value comes out to be +2.5, or you can say 5 by 2, right? 5 by 2 or +2.5, you can call it as the average oxidation state of sulfur in case of your Na2S4O6. I'm sure it's again clear to you, right? Or you can simply use the formula, right? Use the formula and calculate the average oxidation state. It will come out to be same, +5 by 2 only. Right, people? Okay, for decolorization of KMnO4, moles of H2O2 required are, right? First of all, for the decolorization of KMnO4, how many moles of H2O2 are required, right? I hope you remember, I have told you, when H2O2 acts as the oxidizing agent or the reducing agent, its N factor is going to be 2, right? In acidic medium. Yes? So let me call this as number 1, let me call this as number 2. In acidic medium, the N factor of KMnO4 is 5 and N factor of H2O2 is going to be 2, right? Okay, I've told you if it acts as the oxidizing or reducing agent, its N factor in both the cases are going to be 2, right? So for the decolorization of 1 mole of KMnO4, so number of moles of KMnO4 given to me is 1. Moles of H2O2 required, N2 value I'm supposed to calculate. So what is the concept which I'll be using over here? I'll be using simply the concept of gram equivalence. I'll say gram equivalence of 1 reacted should be equal to gram equivalence of 2 reacted. And how do we write the gram equivalence of 1 reacted? It's going to be N1 multiplied by N factor of 1 is equal to gram equivalence of 2 reacted is going to be N2 multiplied by N factor of 2, right? What is the N1 value? N1 value is 1. N factor of 1 is 5 is equal to N2 value. N2 value I need to calculate multiplied by 2, right? So from here, you can calculate the N2 value, which comes out to be 5 by 2, right? So this N2, these are the moles of H2O2 which I was supposed to calculate, right? Yes? So it's absolutely going to be which option? It's going to be option C, which is the correct answer of this question. Similarly, this question, the oxidation number of chromium in potassium dichromate. The question was asked in AIPMT 1988, again in 1995, and in AIMS 1997 as well. 3 times the same question as repeated, right? If you look at K2Cr2O7, it's a simpler one, right? Potassium dichromate, K2Cr2O7, right? So potassium is going to show +1 oxidation state because it belongs to group 1 elements, and group 1 elements, they always show +1 oxidation state, and there are some 2 potassium atoms, right? Chromium shows the oxidation state of X, so it's going to be 2 times X. Oxygen is going to show oxidation state of -2, and there are some 7 oxygen atoms. Net charge is 0, right? When you solve this, you get the value of X over here as +6. So +6 is basically the oxidation state of chromium in potassium dichromate, right? I'm sure it's again clear to you. Absolutely, guys, you all are perfectly right. Yes? Exactly. Okay. One more question, guys. When KMnO4 reacts with KBr in alkaline medium, it gives bromate ion. The oxidation state of Mn changes from +7 to what? What is going to be the answer of this question, guys? You guys let me know the answer of this question. It's a simpler one, right? KMnO4 is participating in the basic medium. I hope you remember, when KMnO4 participates in the acidic medium, it gets converted into Mn dipositive. And when the same KMnO4 converts into the alkaline medium, basic medium, it gets converted into MnO2, right? It gets converted into MnO2. Yes, you can have a look on the reaction as well. MnO4 negative or KMnO4 in basic medium, it gets converted into MnO2. Over here, the oxidation state of manganese is +7. From +7, it gets converted into +4, right? So +4 is the oxidation state of manganese in the species in which this KMnO4 is getting converted into in basic medium, right? As simple as that. Yes? Right, people? So +4 is the oxidation state, which I was supposed to calculate. Which of the following reactions are disproportionation reactions? The question was asked in NEET 2019. Can you let me know its answer as well? Give it a try. Which of the following reactions are the disproportionation reactions? Check it out, guys. Have a look. Copper over here shows +1 oxidation state, and right here it shows +2, right here it's showing 0. +1 to +2, increase in oxygen state, +1 to 0, decrease in oxygen state. So oxidation state of same species is simultaneously increasing as well as decreasing. So this reaction is the example of the disproportionation reaction, right? Similarly, if you look at the second one. So first reaction is the example of disproportionation. What about this one? MnO4 di negative. Oxidation state of Mn is +6. Oxidation state of Mn over here is +7 because it's MnO4 negative, and over here it's going to be +4. So see guys, +6 to +7 increase in oxygen state. Similarly, +6 to +4 decrease in oxygen state. Oxidation state of same species is increasing as well as decreasing simultaneously. So I'll say the second reaction is also the example of disproportionation reaction. Yes. Similarly, oxidation state of manganese over here is +7. Oxidation state of manganese, let's calculate it. +2 plus X minus 8 is equal to 0, so it's going to be +6, right? And over here it's going to be +4. So +7 to +6 decrease, +7 to +4 again decrease. So this cannot be the disproportionation reaction, right? Because oxidation state of Mn in both the parts is decreasing simultaneously. Yeah. If you look at the last one, Mn over here is in +7 oxygen state, Mn over here is in +2 oxygen state, Mn over here is in +4 oxygen state, right? See guys, is it the example of the disproportionation reaction? No, it's not the example of the disproportionation reaction. It is the example of the comproportionation reaction. What is a comproportionation reaction? That is just the opposite of your, when you reverse the disproportionation reaction, it becomes the comproportionation, right? So 1 and 2 are exactly the examples of the disproportionation reactions, and I'm sure it's clear to everyone, yeah? Ganesh, next chapter is chemical bonding, bro, which I'll be starting on Monday, right? The most important chapter, you can say. All right, the correct coefficients of the reactants for the balanced equation. So I need to balance this equation in acidic medium, right? The question was asked in NEET 2018. NEET 2018. Well, people, you can use any of the methods to balance this reaction, and the simplest method by means of which we balance the reaction is going to be the oxidation number method. I hope you know that, right? See guys, I'm just writing something like this. MnO4 negative is converting oxalate ion into what? Into carbon dioxide, and itself is getting converted into Mn di positive. I need to balance this reaction in acidic medium. So which method I'll be using? Let me use the oxidation number method. Have a look exactly. See guys, the oxidation state of manganese over here is +7, oxidation state of carbon is +3, right? Oxidation state of carbon over here is +4, oxidation state of manganese is +2. See guys, +7 to +2, what is the change in oxygen state? 5. 5 is the change in the oxidation state for one atom of manganese, and I've got only one, so its N factor is 1, right? What about the N factor of this oxalate ion? See the change in the oxidation state of carbon, +3 to +4. What is the change? Final oxygen state minus initial. Value comes out to be 1. 1 is the change in the oxidation state for one atom of carbon, but I have two atoms, so its N factor is going to be 2, right? Once you get the N factors, what you are supposed to do after that? You are supposed to crisscross these N factors, right? You are supposed to crisscross these N factors. This should be 2 times, and this should be 1, right? This should be 1 times. Now, let's try to balance all the atoms except oxygen and hydrogen. Have a look exactly. 2 manganese on this side, so this should be 2 times. This should be 2 times. Carbon, 2 on this side, so this should be 2 times as well, right? Since the reaction is taking place in acidic medium, and in the acidic medium we balance oxygen first, right? So how many oxygen atoms do we have on this side? 4 2s are 8, plus 4 comes out to be 12, right? So 12 oxygens on this side, so 2 2s are 4, 4 oxygens on this side, right? So which side is oxygen deficient? Right hand side is oxygen deficient, right? So I'll be adding some 8 water molecules to balance the oxygen atoms. Now check the oxygen atoms will be balanced. Now after balancing the oxygens, let's try to balance the hydrogens, and hydrogens are balanced by H positive ions. So 16 hydrogen on this side, so I'll be adding some 16 H positives on this side as well, right? The reaction is balanced. Yes? Again I did a mistake. Again we did a mistake, right? I told you the N factor of MnO4 negative is 5, but I mistakenly wrote 1. C2O4 di negative, it's getting converted into carbon dioxide plus what? Plus Mn di positive, right? See again guys, N factor of this is 5, N factor of this is 2, right? So this should be 2 times and this should be 5 times, right? So let's try to balance all the atoms except hydrogen and oxygen. So 2 manganese on this side, so 2 manganese on this side, so 10 carbons on this side, 10 carbons on this side, right? Now let's try to balance the oxygens. 8 plus 20, 28 oxygens on this side, only 20 oxygens on this side. Let's add some 8 water molecules on this side. Yes, after adding the water molecules, balance the hydrogens, it should be 8 2s are 16 H positives. Now the reaction is balanced, right? Now the reaction is balanced, right? So what is going to be the correct answer of this question? I need to get the stoichiometric coefficient of what? MnO4 negative, that's 2. Stoichiometric coefficient of MnO4 negative is 2. Stoichiometric coefficient of oxalate ion, that is 5. Right? So option B is the one which is the correct answer, right? Option B is the one. Perfect. Wonderful. Moving on to one more question then. This is one more question, guys. AIPMT 1994. In which of the following reactions there is no change in the valency? In which of the following reactions there is no change in the valency? Basically, you are supposed to see in which of the following reactions oxidation state of elements does not change. Does not change, right? What do you think about this one? Which reaction do you think in which oxidation state of any element is not changing? Let me know fast. Let me know fast, guys. What do you think? What do you think about this one? Right? So people, you are simply supposed to check the oxidation state of elements, right? And I have told you in detail how to calculate the oxidation states of the elements, right? And you're supposed to see that reaction in which the oxidation states of elements won't change, right? So that's how you try to solve this question. That's all. Correct? Perfect. Moving on to one more. Which substance serves as a reducing agent in the given reaction? So which substance is serving as a reducing agent, right? Reducing agent is the one which undergoes oxidation. So basically I need to see which of the substance undergoes oxidation. So just after looking at the reaction, I can say the oxidation state of nickel right here is 0 and oxidation state of nickel right here is +2. 0 to +2, increase in the oxidation state. Increase in the oxidation state is what we call as oxidation. And any substance which undergoes oxidation, that is going to be your reducing agent. So nickel is basically the reducing agent among all, right? Nickel is the reducing agent. AIPMT 1994 again, yeah? Yes? Similarly, guys, let's move on to one more. The oxide which cannot act as the reducing agent, 1995, AIPMT. See, guys, reducing agent is the one which itself undergoes oxidation. Now I need to see which species among all cannot act as a reducing agent. So I need to see which species among all cannot undergo oxidation, right? That species which cannot undergo oxidation, that's going to be the reducing agent, right? See, guys, if you look at this carbon over here, its oxidation state is +4. So carbon over here in carbon dioxide is already present in its maximum oxygen state. It cannot increase its oxygen state. It won't get oxidized. If it is not getting oxidized, so it cannot act as a reducing agent, right? This carbon over here is present in its maximum oxygen state. Yeah? So it cannot undergo oxidation, it cannot increase its oxygen state beyond 4. So if it cannot undergo oxidation, it cannot act like the reducing agent, right? So carbon dioxide is going to be the answer of this question. Yeah? Okay, K2Cr2O7 in acidic medium converts into AIMS 2013. These are the questions, people, which I've shown you in the regular sessions as well, right? You all know K2Cr2O7 in acidic medium, it gets converted into Cr tripositive, by means of which the end factor of K2Cr2O7 comes out to be 6, right? Okay, so K2Cr2O7 in acidic medium gets converted into Cr tripositive. Similarly, MnO4 negative in acidic medium gets converted into Mn dipositive. That's something which you know too, yeah? All right, one more. AIMS 2014. What is the oxidation state of bromine in this compound? See, guys, potassium is a group first element, and group first element, they always show +1 oxygen state. Let's assume the bromine has got the oxygen state of X. Oxygen is going to show -2 oxygen state, and there are 4 oxygen atoms. Net charge is 0. The value of X over here comes out to be +7. So +7 is the oxidation state of bromine over here, right? Yes, as simple as that. +7 is the oxygen state. Yes? Exactly. Moving on to one more. The question was asked in AIMS 2016. Substances that are oxidized and reduced in the following reaction are respectively. Substances that are oxidized and reduced in the following reaction. Check it out. Nitrogen's oxidation state, let's calculate it. It's going to be 2x plus 4 is equal to 0. So X value will come out to be -2. So -2 is the oxidation state of nitrogen over here. Oxidation state of oxygen, -1. Hydrogen peroxide. In hydrogen peroxide, oxygen shows -1 oxygen state. Nitrogen does not have any charge over here. Oxygen, -2 oxygen state. See, guys, -2 to 0, increase in the oxidation state. Increase in the oxidation state is something which I call as oxidation. And that species which undergoes oxidation, that is going to be acting like a reducing agent. So N2H4 is going to be the reducing agent. -1 to -2, decrease in the oxidation state, means reduction. And any species which undergoes reduction, that will be acting as the oxidizing agent. So I identified which one is oxidizing agent and which one is reducing agent, right? So H2O2 is the oxidizing agent, right? Okay. Substances that are oxidized I'm not supposed to see which one is oxidizing agent, which one is a reducing agent. I'm supposed to see which one undergoes oxidation and which one undergoes reduction. So this N2H4, increase in oxygen state, it undergoes oxidation, and this undergoes reduction. H2O2 undergoes reduction, right? Okay, so this is undergoing oxidation, N2H4, and H2O2 is undergoing reduction. Or you can check the oxidizing and reducing agents as well. Yeah, as simple as that. Correct, people? So it's going to be absolutely option B, which is the correct answer of this question. Increase in oxygen state means oxidation, decrease in oxygen state means reduction. Yes. Now people, have a look on one more. The oxidation number of hydrogen in KH, MgH2 and NaH are respectively Ames 1998, right? Let me know its answer, guys. Yes, Mursaleen, you can do that. What is going to be the answer of this question? People, I hope you remember, I've told you in the regular sessions, whenever hydrogen will be attached to a less electronegative element than itself, the oxidation state of hydrogen will be taken as -1, right? And all the group first elements and group 2, group second elements, group 1 and group 2 elements, their electronegativity is less than that of hydrogen. So whenever hydrogen will be attached with any of the group first element or with any of the group second element, the oxidation state of hydrogen will be taken as -1. So over here, hydrogen is attached to group first element -1, hydrogen attached to group second element -1, hydrogen attached with group first element -1, right? So everywhere, hydrogen is showing -1 oxygen state. So it's absolutely going to be option C, which is the correct answer of this question, right? Yes. Okay, oxidation state of sulfur in S8, H2S and S2F2. See guys, in case of S8, the oxidation state of sulfur is going to be 0. What about this one? Just do the crisscross thing. It's going to be -2, right? What about the oxidation state of sulfur over here? It's going to be +1. As simple as that, you can check. 2x -2 is equal to 0, so x value will come out to be +1. So 0, -2 and +1, 0, -2 and +1. These are the respective oxidation states of sulfurs in them, right? Yes? Yeah? I'm sure it's clear. And people, we have discussed these two, right? Okay, JEE Mains 2017. Which of the following is an example of redox reaction? What is a redox reaction? Any reaction in which oxidation and reduction takes place simultaneously, right? Any reaction in which oxidation and reduction takes place simultaneously. You are simply supposed to see in which of the following oxidation and reduction is taking place simultaneously, right? That's simple to check. Oxidation state of xenon over here will come out to be +4 when you solve it. Oxidation state of oxygen will come out to be O2F2. In case of O2F2, the oxidation state of oxygen is +1, right? I hope you remember the structure of O2F2, in which the oxygen shows +1 oxygen state, right? I hope you know that. Xenon over here will show +6 oxygen state and oxygen will show 0. So +4 to +6, increase in the oxygen state means oxidation, right? +1 to 0, decrease in the oxygen state means reduction. So in the first reaction only, oxidation as well as reduction, both are taking place. So first reaction only is going to be what? First reaction only is going to be the redox reaction. Yes? Right? Yes, exactly. Sivari, I'll be conducting the same session on JEE Enthuse channel as well, in which I'll be doing the previous year questions which have been asked in JEE Mains and JEE Advanced from the same chapter, right? Not today, maybe on Monday or Tuesday. Yeah? Okay? Let's move on. The values of X, Y and Z are respectively. I think we solved the same question a few minutes back only, right? I think we solved the same question a few minutes back only, correct? Right, guys? This was, I guess, 2 times, this was 5 times, and this was 16 times. Few minutes back only we solved the same question. And the same question was repeated in AIEEE 2013. Yeah? Absolutely. It's going to be option 258 it's showing. No, it is 2516, right? What do I need to see? X, Y and Z. So wait. This is X, this is Y, this is Z. So it's mistakenly given as option B, but it's not going to be option B, it's going to be 2516. The correct option is going to be option C, right? So it is this P part over here, it's going to be option C, 2516. This is the correct answer of this question, right? As you can see over here, we have balanced it a few minutes back only, right? So it's going to be 2516, yeah? Perfect. Moving on to one more then. Okay, there are not more questions, right? These were the questions which have been asked till now in different medical competitive examinations from the chapter Redox, and I'm sure you would have killed them if you would have seen the Redox sessions properly, right? Okay, and people, maybe tomorrow I won't be taking any session. On Monday we'll be starting chemical bonding on this channel, right? And on Monday on Vedantu JEE English channel, I'll be doing the previous year questions from the same Redox reactions which have been asked in your JEE Mains and JEE Advanced, right? Okay, and before ending the session, the ones who want to join us on our actual Vedantu platform, who want to get trained by us on the actual Vedantu platform, let me tell you, one new batch has recently started on 27th of September, right? On the last Monday. You can still enroll into that batch, right? You can still enroll into that batch. And in order to enroll into that batch, you need to take any of these plans, and all these plans you can take for a month as well, right? In order to check. If you are taking light plan for a month, you need to pay this much of amount. If you're going for classic plan, right? Okay, if you want to give it a try for a month, right, you can do that. Vedantu has kept an option for that. And if you want to go for plus program, again you can give it a try for a month, right? What is the difference in all the three? What is the difference in all the three? First of all, you can take all these plans for a month. You can sit into that batch, right, for a month by taking a subscription for a month, right? If you think you are getting benefited in this month, I mean, right, then you can enroll yourself in the 2-year classroom programs, right? And I'm sure you're going to like it, you're going to love it, right? You'll eventually enroll yourself in the 2-year classroom program. What is the difference between these three plans? If you're enrolling into the batch which started on 27th of September through this light plan, you'll be getting live interactive online classes, test series analysis, study material you'll be getting, doubt solving during the class, right? All these things will be covered in this plan. But in the second plan, what is something which is extra over here? You get doubt solving on mobile app. You'll be given an app from Vedantu in which whenever you feel any sort of doubt, you need to write your doubt in the app, and at that time itself your doubts will be getting cleared, right? And what about the plus? What is different in this? In plus, you get personal mentors in all the three subjects, physics, chemistry as well as biology. So people, it's my personal suggestion for you guys to take it for at least a month, right? See how the actual Vedantu platform looks like, apart from the YouTube sessions, right? Okay, actual Vedantu platform is different, YouTube sessions are different, right? Yes, so you can take any of these plans, just see for a month, right? You are absolutely going to fall in love with the actual Vedantu platform, right? And how to enroll, how to get any of these, how to enroll in the batch which has started on 27th of September, right? People, this is the code which you guys are going to use, and after using this code you'll be getting some 20-30% off as well, right? And let me show you exactly after a few minutes how to get enrolled into the batch by means of any of these pro subscriptions. Before that, let me tell you, there is one more link in the description box of the video. You need to click on that link, right? Get added to the Telegram group, stay updated about the classes, and the ones who have not liked the video, please do like the video, share the video with your friends, do subscribe to the channel, right? So let me show you exactly how to get enrolled in the batch which has started on the actual Vedantu platform on 27th of September. See guys, this is the video which you guys are currently watching, yeah? You need to drag it a little down, click on this show more. After clicking on this show more, drag it a little more down. You can take any one of these courses over here, right? The first course is CBSE Science Term 1 Crash Course. If you want to have the crash course for Science for the Term 1, right, you need to click on this link. If you want a CBSE Term 1 and Term 2 Crash Course, click on this link. Grade 11 and 12 Science, click on this. If you want to enroll into NEET 2-year classroom program, whose link I was showing a few minutes back, right? You need to click on the link. After clicking on the link, you need to choose the plan. If you are going for light, click on this. If you are going for classic, click on this. If you are going for plus, click on this. For example, I'm going for light, right? And over here, you need to use the coupon code WSPRO, right? And after using this, you'll be getting some additional 10% off, right? Well, you can buy the complete course or you can try it out for a month. Let's assume I'm trying it out for a month. I need to click on this. After clicking on this, you need to give your number, your email ID, in which you'll be getting the OTPs and everything, through which you'll be getting automatically enrolled into the batch which recently started on 27th of September. So do get enrolled in it, at least for a month. You're absolutely going to fall in love with the actual Vedantu platform and with the teachers who teach internally on the actual Vedantu platform. Trust me on that. So we will, with this, I'll take a leave. I'll see you guys tomorrow at the same time. Till then, you guys take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.